Good morning. Today we will discuss about Unit 2 of Limit State Design RCC. This chapter includes different types of special concretes which are generally used. It includes high performance concrete, self compaction concrete, fiber reinforced concrete, ready mix concrete, reinforced cement concrete, and it also includes introduction, definition of limit state design. It contains limit state collapse, durability, serviceability, characteristics, load and strength, and assumptions made in limit state design. First, we will study about high performance concrete. High performance concrete is a concrete in which certain characteristics are developed for a particular application and environment so that it will give excellent performance in the structure in which it will be placed. A high strength concrete is always high performance concrete, but a high performance concrete is not always a high strength concrete. High performance concrete meets special performance and uniformity requirements that cannot be achieved by conventional method of concrete, by normal mixing, placing and curing practices. High performance concrete is a concrete in which some of or all of the following properties have been enhanced. That is, ease of placement, long-term mechanical properties, early age strength and toughness. The main components of high performance concrete is the admixtures which are added in the form of mineral admixture or chemical admixture in addition to cement, sand, aggregate and water. The mineral admixtures are pozzolanic supplementary cementitious material. They will used for filler material, and the chemical admixtures are plasticizers, super plasticizers, retarders, air entering agents, etc. as per their requirements. The most important characteristics properties of high performance concrete is very high resistance to chemical attack, atmosphere and development bonding, low porosity, permeability, low heat of hydration, low water binding ration and almost segregation, bleeding, shrinkages are avoided. The most important advantages of high performance concrete: it is highly resistant to permeability, electricity, fire and seismic resistance due to earthquake, etc. It has high abrasion strength, tensile strength, durability, It increases the speed of construction, which reduces the cost of construction and maintenance cost. The general applications of high performance concrete is in construction of bridges, piers, and pavements like airports, railway stations, harbors, and skyscraper, high-rise buildings, floor slabs, tunnel linings. High performance concrete is being increasingly used in highway pavements, fast track concrete pavements. Next component is self compaction concrete. The term itself indicates that the concrete which will be compacted because of its own weight is called self compaction concrete without any external vibrators. Concrete that is able to flow and consolidate under its own weight by filling formwork evenly, even in the presence of dense reinforcement with homogeneity. The concrete is versatile material extensively used in construction throughout the world. Properly placed and cured concrete exhibits excellent compressive force adjusting characteristics. If the consolidation is made minimum, the strength of concrete will not affected. In architectural other important works, self compaction concrete is used. In 1980s, these types of concretes are introduced in Japan. Self compacting concrete offers new possibilities and prospects in the context of durability and strength of concrete. Adjustment of water cement ratio and super plasticizers, admixtures are important in self compaction concrete mixture. The important to verify the mechanical properties of self compacting concrete before using it for practical applications, especially if the present design rules are applicable for if they need some modifications. Next is fiber reinforced concrete. As we know, concrete is very strong in compression and weak in tension. To make it strong in tension, we will reinforce with some additional fibers in the form of steel, glass, synthetic fibers, asbestos, etc. It is a composite material obtained by adding single type or blended of fibers in conventional concrete mix. The main role of fibers is to bridge the cracks that develops in concrete and increase the ductility of the concrete. There is a considerable improvement in the post-cracking behavior of concrete containing fibers due to both plastic shrinkage and drying shrinkage. They also reduce the permeability of the concrete and reduces bleeding segregation of concrete. The different types of fibers used in concretes are steel fibers, glass fibers, carbon fibers, cellulose fibers, polypropylene fibers, nylon fibers, natural fibers, wire, hay, asbestos, etc. The most important advantages of fiber reinforced concrete are they are having high flexural strength, highly resistance to water, fire, atmosphere, ideal aspect ratio, that is relationship between fiber diameter and fiber length, which makes them excellent for early age performance. Easily placed, costed, sprayed, and less labor is required for working. So this is the comparison between fiber reinforced concrete and normal reinforced concrete. Fiber reinforced concrete have high durability, lighter material, more expensive, less workability, and having more strength for the same quantity of volume with respect to normal concrete. The application of fiber reinforced concrete is more versatile. It is used in runway, aircraft parking, pavements, harbors, docks. It can be used in taxiways, aprons, parking areas, tunnel linings, stabilization of slope. Steel fiber reinforced concrete are being used in openings, rock slope stabilizations. It eliminates the need of mesh reinforcement and scaffolding, thin shell walls, pipes, manholes. Fibrous concrete permits the use of thinner, flat, and curved structural elements. It is also used in agricultural purpose, animal storage structures, walls, silos, precast concrete products, architectural panels, septic tanks, and roads and sculptures. It also used in irrigation structures like dams, retaining walls, canals, notches, weirs. Next is ready mix concrete. Ready mix concrete we will discuss in later class.